Hello, today we will be adding and subtracting rational functions. Rational functions are simply fractions that have variables in the numerator and the denominator. So remember, in order to add fractions, you must have a common denominator. Once we have a common denominator, all we have to do is add or subtract the numerators and keep the denominators. So let's look at an example from just regular fractions. So not rational functions because there's no variables, but let's think about the process for adding fractions. The first thing you have to do is come up with a common denominator. In this case, the common denominator is 21 because it's 3 times 7. So what you would do is change both denominators in your addition problem to 21. Then you think, what times this denominator 3 gives me 21? That would be 7. So I multiply 2 times 7, and that gives me 14. What makes the denominator 7 turn into 21? I would multiply by 3. So I multiply the numerator by 3 as well, and I get 3. The final step would be to add the numerators, but keep the denominator of 21. So 14 plus 3 would give me 17 over my common denominator, which is 21. At that point, you would reduce if possible. In this case, 17 over 21 does not reduce, so that is your final solution. So now let's look at some rational functions. Remember that rational functions have variables in the denominator, but that doesn't really change the way we find common denominators. So the first thing you think is, what is the common denominator of 5x and 9? 5x times 9 would be 45x, so that's your common denominator. The next question is, how do you change the first fraction, 3 over 5x, to have that common denominator of 45x? What you would do is multiply both the numerator and the denominator by 9, because 9 times 5x gives you that 45x. How do you change the second fraction, 2 over 9, to have the common denominator of 45x? You would multiply the numerator and denominator, this time by 5x. So, as we said before, the common denominator was 45x. So I write out my common denominators, 45x plus 45x. Now we said to multiply the first fraction, the numerator and the denominator, both by 9. So 3 times 9 gives you 27. For the second one, we were multiplying by 5x. So 2 times 5x is 10x. So for my solution, I keep the denominator of 45x, and I add 27 plus 10x. If you remember standard form, you want to always write your variables from highest exponent to lowest, so you would actually start with 10x plus 27 for your final answer. And this should say 45x in your denominator. So your final solution should be 10x plus 27 over 45x. For my next problem, we're going to look at what if you have a binomial, meaning 2 terms, as one of your denominators. The good thing about this is that you still create common denominators in the same way. So let's follow the steps below. Looking at my first problem, the denominators are x plus 1 and 7. So the common denominator is just multiplying 7 times x plus 1. It's okay to leave it in factored form, so you don't have to multiply, you don't have to distribute your 7. You can just leave it as 7 times x plus 1. So you write out your two denominators, 7 times x plus 1 plus 7 times x plus 1. And now we need to figure out what are our numerators. For my first fraction, I already have x plus 1, so I just need to multiply the numerator and the denominator by 7. So 2 times 7 gives me 14. For the second one, I already have the 7, but I don't have an x plus 1. So I need to multiply my numerator and my denominator by x plus 1. That leaves me with 4 times x plus 1. Now, in order to add these together, I do need to simplify the top. So I am going to want to multiply through on top and add together any like terms. So to start that, I have 14 plus then I distribute 4 times x gives me 4x, 4 times 1 gives me 4. I can go ahead and combine them, put them on top of on the numerator with my common denominator of 7 times x plus 1. Now I just simplify my numerator if I can. In this case I can because I can add 14 and 4. They're like terms. So my final solution is 4x plus 18 over 7 times x plus 1. So now I want you to try this next one. It's just like the one we just did. You've got a number and a binomial. So pause the video and try that problem. The solution is written down in the corner. So the common denominator is 8 times x minus 4. So you write out your two common denominators. For the first one, I have the 8, so I need to multiply the numerator and the denominator by x minus 4. So I have 5, that was already there, times x minus 4. For the second one, second fraction, my denominator is x minus 4, so I still need the 8. I multiply the numerator and the denominator by 8. So that gives me 48. So again, you do want to distribute 5 times x and 5 times negative 4 plus the 48. So I combine them into one fraction with the common denominator. And then I can add my like terms. So I end up with my solution, which is 5x plus 28 over 8 times x minus 4. Because remember, you can combine negative 20 plus 48, and that would give you the 28. Okay, now looking at another example. For this one, the common denominator actually has 3 parts. We have an x plus 3, but we also have an x minus 2. I need all 3 of those factors as my common denominator. So anything in either denominator has to be included in your final common denominator. So I have my x plus 3 times x minus 2 as my common denominators. On top, so I have, for the first fraction, I have x times x plus 3. The only thing missing is x minus 2. So I'm going to multiply my 7 times x minus 2. For the second one, I'm missing the x and the x plus 3 because all I have is the x minus 2. So I'm going to multiply the top by x and x plus 3. Notice, I brought the minus sign up with the 1 and made it negative 1. And now I can multiply all 3 of those together on top and make it an addition problem. So, distributing my 7, distributing my negative 1x, I end up with 7x minus 14. And then negative x times x is negative x squared. Negative 1x times 3 is negative 3x. Now I'm going to need to combine any like terms I have. So I have, and put it in standard form. So my final solution gives me negative x squared, 7x minus 3x is 4x, minus 14, all over my common denominator of x times x plus 3 times x minus 2. So now it's your turn. First, start by figuring out your common denominator, and then multiplying your numerators by whatever is missing from each fraction. Pause your video now and take a moment and try that. So for the common denominator, you should have found x squared, x minus 1, and x plus 5 because you need every part of the denominator to be in your common denominator. So I rewrite my two common denominators with a plus sign. For my first fraction, I already have x squared and x minus 1, so I need to multiply the numerator and denominator by the x plus 5. So I have 10 times x plus 5. For my second fraction, I already have x plus 5, so I need to multiply by x squared and x minus 1. So I brought the negative 6 up, so minus 6, negative 6, times x squared times x minus 1. When I multiply through on each numerator and combine them onto one fraction, I end up with 10x plus 50 minus 6x cubed plus 6x squared. Then all you need to do is put it in standard form and combine like terms if you have any. And that's how you get your solution of negative 6x to the third plus 6x squared plus 10x plus 50 over your common denominator. So now looking at one more example. Now the two fractions already have one thing in common in the denominator. So our common denominator does not need all four of those factors. I only need one of each factor. So I need an x plus 1, an x minus 1, and an x plus 2. I do not need to put x minus 1 again. So because they already have x minus 1 in common, I only need x minus 1 one time in my common denominator. So that means my new common denominator is x plus 1 times x minus 1 times x plus 2. So I write that at the bottom of each fraction. For the first fraction, the only thing missing from my common denominator is the x plus 2. So I'm going to multiply the numerator and the denominator by x plus 2. So I'm going to multiply my x minus 2 that was there times x plus 2. For the second fraction, the only thing missing was the x plus 1. So I'm going to multiply the numerator times x plus 1. When I multiply x minus 2 times x plus 2, I get x squared minus 4. And when I multiply 9 times x plus 1, I get 9x plus 9. So then my final answer is just to simplify the numerator by putting it in standard form and combining any like terms. So my final solution would be x squared plus 9x plus 5 over my common denominator. So for the last problem is one for you to try. Note, they do have a common factor, so you only need to write that common factor once in your common denominator. Pause the video now and try that you try problem. So the common denominator is x times x plus 2 times x minus 3. So I have x minus 3 in both fractions, so I only had to write it one time. So I rewrite my two denominators. The first fraction is missing just an x. So I'm going to multiply the numerator and denominator by x. The second fraction is missing x plus 2. So I'm going to multiply the top by x plus 2. When I distribute those out, I end up with x squared minus x plus 9x plus 18. Now, combine your like terms on the numerator and put it in standard form, and that's how you get your solution of x squared plus 8x plus 18 over your common denominator. So to recap, when you are adding or subtracting rational functions, you need to come up with a common denominator, and then you need to multiply your numerator by whatever that fraction is missing to make the common denominator. Then you add your fractions together by adding the numerators and keeping the common denominator. Your final answer should have the numerator in standard form with all like terms combined and over your common denominator.